Hi all, welcome to those who have just logged on. I know a few of you have been logged in a little while, so I hope you've tried the starter there. I'm going to give you a few more minutes just for those who are just logging on now. So see if you can match up the increase and decrease percentages with their multipliers, because we're going to be using that skill a lot today. As always, if there's any questions, just type them in the chat box. There's a bit of a lag, but I'll hopefully see them as soon as possible and get back to you. Apologies again that I wasn't able to do this yesterday. The internet is going down at the moment slightly, but hopefully today's session will be all right. Okay, I'll give you another minute or so to have a go at those starter questions. All right, just one more minute at the starter questions. Hopefully some of you saw that you could download the presentation in advance from my website. It's quite handy to do that because then you can write on it, just a bit easier than trying to scribble these down and match them up. And also you can start the starters before the session if you know that it often takes you a bit of time to log on, or once you've remembered about it. Then printing out just 1 or 2 slides can be quite handy. All right, should we go through them? Hi to those who've just joined. We're just about to go through this starter. So we're going to have a look and see which percentages match up with their multipliers. The first one should be the top ones there. We've got down by 33.33% is multiplying by 0.6 recurring. That's because you could think of the 33.33 as 33.3 recurring, and then it's a bit easier to see the match up. We've got down by 25% is the same as multiplying by 0.75. That's because if you've decreased by 25%, you've got 75% left. So that's what we're trying to work out here, what's left really. If we go up by 33.33%, we are multiplying by 1.3 recurring. So we've got 133.3%. Okay, the next one, down by 20%, is multiplied by 0.8, because if we reduce by 20%, we've got 80% left. Up by 20% should be multiplied by 1.2, because we've now got 120%, and that as a decimal is 1.2. The next one, down by 16.2% is multiplied by 0.83 recurring. Now that's because 16.2, remember 2/3 is 0.6 recurring. So we've got 16.6 recurring. We've got to work out what's left to bring that up to 100% and work that out as a decimal. Our next one, if we want to go up by 50%, we multiply by 1.5 because we've now got 150%. And the last one, if I want to go up by 100%, I times by 2. Because I've now got 200%. I don't know whether that's buffering for you. I apologise if it is. Right, I hope that's okay and has been a bit of a brief recap of how to use our multipliers. I'm going to show you what we're going to be talking about in our session. So we've got 5 little topics that I'm going to go through with you, and then you're going to have some practice at the end and a chance to see kind of how you do on all those questions. So the first one we're going to look at is percentage change. And if you have a look at the formula on the left, this one needs to be something we're really familiar with. So it needs to be something that as soon as you see a question that's asking about percentage change, then that's what we think of. So it's new take away old, divided by old, and then you multiply by 100 to get the percentage. So I'll show you with the first one how we do this. Laura used to get £2.50 pocket money. She now gets £3. What was the percentage change? So first off, I'm looking for that new in our formula. And the new is that now gets £3. If you can hear me at the moment, could you just type something in the box saying yes? Because on my screen it's just buffering. I just want to make sure it's connecting. So if you're watching and you can hear at the moment, could you just type yes for me? Perfect, thank you. Thanks for making that. Sorry, it's buffering on my screen. I just wanted to check you could hear me. Fab. So the new is that she now gets £3. So we're going to start there. Take away the old. So the old was that she used to get £2.50. So used to get £2.50. That's the old amount. And we've got to divide by the old as well. So divide by our £2.50. We then times by 100 just to make it a percentage, because that would give us a decimal answer. If you bung that into your calculator, you would get an answer of 20. Remember, we've made that a percentage, so that actually means percent, 20%. Now, to get all the marks on this question, it said what was the percentage change. And if you look at this little pink bubble at the bottom, you've got to remember whether to specify whether it is an increase or decrease. So that is a 20% increase. So you've got to write increase or decrease if it just says change, because it wants you to tell what's happening. It's always easy to go back to the question, just use your common sense what's happening there. All right, you have a go then at the one beneath that, the blue box, and I'll go through it in just a minute. Right, should we have a look at this one together? So we've got the new minus the old. So they changed from $30.01 to $27.10. So the new is this 227 this time. So I'll just use the same colour as before. 27.10. Take away, and we've got to take away the old, which was 30.01. Divide by the old, which was our 30.01, and then times by 100. Put that into your calculator and you should get out, this time it's a negative answer. We get minus 9.6967 ... Now the negative just means that it's a decrease. And you can see that from the question, it's gone from $30 down to 27. So we don't need to write the negative in our final answer. We can also round this, we don't need to continue it forever, but write down what you're rounding to. So I'm going to say that is a 9.7% decrease. And remember, we have to write down, that's what's happening with my stylus either today, right, that it is a decrease because it just said calculate the percentage change. Okay, hopefully that's clear there. So it's always new, take away old over old, times by 100, and see what you get. Now don't worry, if you get the top ones the wrong way around, you'll still get the difference. It just won't be positive or negative at the end in the right way. But always look back at the question to check that it's what you're expecting. Are you expecting it to be a decrease or an increase? It's basically the difference divided by the old. Okay, let's go on to number 2, and you'll have a chance to practice these in a second. So the second part of percentages I'm going to walk you through is simple interest. Now this one, it's such a tiny little topic because we spend a lot of time learning about compound interest, but you have to know the difference, because if a question asks you about simple interest and you use compound interest, you won't get any marks for it. So let's go through an example and then you'll have a practice. So in this case, in simple interest, every single year the interest is based on the original value. So in this case here, we've invested £1,000. We're going to get 10% of that £1,000, and that interest will stay the same each year. It won't rise the more money you get in your account like normal compound interest. So the way to do this is we work out the original interest. So to find 10% of 1,000, I'm just going to times by 0.1. Obviously you could just divide by 10 there, but I want to show you how it would work for any percentage, because in a second yours is a bit more challenging. So you multiply by the multiplier. 1,000 times 0.1 equals £100. So that's our interest we get. Now we get that same interest each year. It's invested for 3 years, so we'll get that 3 times. So in total, we will get £300 in interest. Now that means at the end of that time, you will have £1,300 in your account. Okay, you have a go then. Try this question at the bottom there. Okay, should we go through this one together? Let's see how we've done. So we start off with $500. It's 6.25% interest. Now that as a multiplier is 0.0625. Make sure you've got that extra naught after the decimal place, because otherwise you've done 62.5% interest, which would be an amazing amount of interest. So 500 times 0.0625, and that would give us 31.25. So that's the interest we get every year. And remember, it's the same because it's simple interest, just stays the same every year. Again, this one is for 3 years. So we do 3 lots of 31.25 and we get 93.75. Now in this one it said find the simple interest. It didn't say find the final amount, it just said find the simple interest. So that is just your answer. It's in dollars, 93.75. So I didn't mean to try and catch you out there, I just wanted to show you the different types of questions. So if it says find the final amount, then you would add it on to your original like I did in the first question, although it was a badly worded question for that example. But in your turn, it said find the simple interest. So it just wants the interest you receive. Okay, again, you'll get a chance to practice that at the end. So that's 2 out of 5 skills. Let's have a look at the third. So we're now going to move on to compound interest, the one that you spend most time. Oh, sorry, what someone's just said, wondering in real life, when would you use simple interest? I know, I have honestly never seen it used in real life. Honestly, and it sounds appalling saying that as a maths teacher. They've introduced it in the new GCSE a few years ago when they changed the method that you had to know the difference. And I can't see why. I'm sorry I don't have a better answer than that. It's terrible. No one would want simple interest. You'd want compound. So apologies, I do not have a better answer for you. Compound is the most common and would actually help you in real life. So let's have a look at the example for compound. We've got £180 and it's going to be invested at 8% compound interest for 4 years. So we start off with our £180. If it's invested at 8% compound interest, I can just increase it by 8%. I'm going to increase it by 8% each year. So that's the same as multiplying by 1.08, because remember otherwise 1.8 would be increasing by 80%. That would be the first year. The second year, the new amount would then increase by 1.08 again, and then again, and then again. So that would happen each year. The new amount would keep being increased. Now, hopefully you've spotted or remembered that a quicker way to write this would be using a power. So that is the same as 180 times 1.08 to the power of 4. And that would give us our answer of 244.888 when you put it into your calculator. As it's money, unless they ask you otherwise, round it to 2 decimal places. So I would write my answer as that. Always specify, I don't think I wrote on the last example, apologies about that, but always specify if you have rounded. So write down 2dp in brackets. So that is actually a formula that we can remember and we can use for this. And if you see down there in the bottom left-hand corner, I've taken this example, but you've always got your starting value multiplied by your multiplier, and then the power is your time. So whether it's the years, the days, whatever unit the question is in. You have a go then. Have a go at that question beneath it. All right, should we have a look and go through this one together? Just going to zoom in so I can write on that a bit easier. Right, so this time our starting value is 470. We're increasing by 12.5%. So our multiplier is 1.125, 112.5%. For 3 years, so our power is 3. Plug that into your calculator and you should get, which rounds to £669.20 to 2 decimal places. Final answer. So it's simple enough once you know the formula. It's just remembering starting value, multiplier, time. Okay, hope that's all right. Now those were all with increases. And our fourth example of percentages today is going to be with a decrease. So this is the same formula, but for depreciation, which means when it decreases, like here, the cost of a car. Typically you have costs of houses, things like that depreciate over time. So if I work through this first one with you, and remember it's exactly the same formula. So our starting value is 12,000. Now our multiplier, if it's depreciating by 10%, our multiplier is going to be 0.9. Remember, like in that starter, it's gone down by 10%, so we want to find 90%. Now work out the value of the car 2 years after he bought it. So just to the power of 2. Plug that into your calculator and you get 9,720. Okay, exactly the same formula. It's just noting that our multiplier is generally going to start with a 0 if we're depreciating, because it's going to become less than 1. Okay, you have a go. Right, are we ready to go through this one? Let's have a look. So our starting value this time was the number of flamingos in a colony, and it was 7,000. Decreasing at a rate of 14% per year. So think about what's left if you take away 14 from 100. We've got 86%. So our multiplier is 0.86. Now we're going from 2017 to 2022, so that's 5 years on, 8, 9, 10, 11, 12. So our power is going to be 5. Put that into your calculator and we get 3,292 and then a few decimals after. Now think about what a sensible degree of accuracy would be for this question. It said, how many flamingos are expected to be in this colony? We wouldn't expect to see 0.9 of a flamingo, so we're going to round this to the nearest whole number. So in this case, it rounds up to 3,293. But again, always write down what you've rounded to. So in this case, that's 0 decimal places, 0 dp. Okay, hopefully we got that one. Let's try our last percentage review. And this one is going to be reverse percentages. So let's have a go at this, and then you've got some time to practice yourself. Now just have a look at the formula down the bottom there, or the diagram. I would say I've written in big pink there, draw the diagram every time. I say this right the way through to my year 11s, right the way through to their exam, because it's so easy to get it wrong. But if you draw the diagram, you will get it right, because it makes you think about it, makes you think about the way it goes. You also do the diagram clockwise. So you start at the clock, like you're at midday, or 12 o'clock, and you go clockwise, 1, 2, 3, and so on. So I'll show you how it works with this first example, and then you can try it. But I really would say use this diagram. So let's have a go. Oh, I'm not actually just going to click through this one, because it's a bit easier. A value of a painting went up by 25% and is now valued at £400. So if it went up by 25%, the multiplier, is 1.25. So that's what we start with. Right at the top is our multiplier. It's gone up by 25%, so that means it was multiplied by 1.25. It is now valued at £400. So we can add in the £400 at the 3 o'clock mark. That's everything from the question, but we can use our diagram to undo that and go backwards. So the opposite of multiplying by 1.25 is dividing by 1.25. So all we've got to do to find the answer is 400 divided by 1.25, and you get 320. So it shows you that it originally cost £320. So again, just to recap with that diagram there, start with the multiplier right at the top. So look at the question. If it's gone up by 25%, our multiplier is times 1.25. If it had gone down by 25%, our multiplier would have been times 0.75. It's always going to be a multiplier at the top. That's where you start. Then follow it around clockwise and see where you go. You have a go at this question then, and I'll go through it in a second. Make sure you're drawing out that diagram. Okay, shall we see how we've done? Now remember, we start with the multiplier. So in this question, it says an item costs £93.50 after a 15% discount. So 15% discount, the multiplier would be multiplied by 0.85. Remember, it's always a multiplier, 0.85. Then we got to the item costing £93.50. Now we have to reverse it. So to go backwards, we have to divide by 0.85. And we will get an answer of £110. So well done if you got that. It originally cost £110. Now I would say if you tend to get these ones wrong in an exam, then this diagram, I know I'm banging on about it, but it really does help, because so often people tend to divide by the wrong thing. They'll divide by 25%, or in that decrease one, they'll divide by a 15%, and it gets confusing. Whereas I think if you've done the diagram, you can see how it works every time. Okay, let's try and put some of this into practice then. You have got a mixture of questions here. I've given you all three formulas that we've looked at today on the left. So we've got our percentage change at the top, then we've got our interest or depreciation for compound interest, and at the bottom there we've got our reverse percentage diagram. All the questions are mixed up, so you won't know what topic they are, because that's often the tricky bit with percentage, trying to work out what you need to use. At the bottom is a slight extension question. Do them in any order if you want. I'm going to mute myself for a minute and give you a few minutes to have a go, and then I'll go through answers. If you don't finish all the ones you want to in the time I give you, don't worry, you can always go back and watch this again and pause it and give yourself a bit longer. All right, off you go, have a go. Right, I'm just giving you one more minute, so I reckon you can do one more question in that, and then we'll go through some answers. One more minute. Right, let's see how you got on. Remember, if you didn't have much time to do many then, don't worry. All of these slides are available on my website, so you can do them in your own time, or you can watch this video once it's gone live again, or once it's on YouTube, and pause it so that you've got more time. Also, it might be a bit blurry for you on this screen because it's live. It kind of has to sacrifice some quality. So it might be a good side to have it even digitally, just the PowerPoint presentation from my website alongside, because you might find it easier to read. Okay, let's have a look at some of these answers. If you've got any questions, do type them in the box now and I'll go through a question for you. I'm not going to go through them all, but if you've got a query or one you're not sure of, have a look at the little bit of method I've written. If you want me to go through it, I will. If you're doing these again in your own time a bit later, then just type a comment in the box on the video and I'll get back to you. I'll try and help you where I can, because some of these it just needs a little, it'll be one little bit of misunderstanding. That's all it is. Okay, I hope we've all managed to mark them. If not, remember you can go view this video, pause it, mark in your own time. Just wanted to remind you about the next session, which is tomorrow, 5 p.m. on this channel, and we'll be recapping simultaneous equations. So there's going to be a lot of different content to do in that session. The slides will be ready later today when I upload them for you to download. If they're not quite ready tonight, they'll definitely be up before the session, so do check back tomorrow if they're not quite there. If you could give this video a like if you found it helpful and subscribe to my channel, that would be really helpful. And also if you can get the word out there, that would be fab. I'm trying to promote it on Facebook, which I think is more like your mums are using and telling you about. I'm also trying to promote it on Instagram, but I'm a bit new to all that. So if you've got a good hashtag you know of, let me know. And I'm trying to get the word out there. All right, but otherwise, more practice questions can be found on Coolbit Maths. I've put the links to the videos there. And I'll see you tomorrow for simultaneous equations at 5 p.m. All right, bye for now.